timely and impactful subject matter, and we look forward to sharing our insights with you on this. So to begin, I'll kick things off. I'm Wade Lee. I have over 25 years of experience in business development with some of the largest IT companies out there, but my niche has really been working with the high quality, innovative solution powerhouses such as SPS. Now, Gene Willard will delve into what I refer to as the problem emerging in AI projects today. Now, Gene speaks with authority, okay? He's led several AI initiatives over really a stellar career as a CIO and a CISO. He pioneered the development of the first AI application at a major hospitality corporation, which resulted in significant revenue growth and really a competitive advantage for that chain. He later led the adoption and integration of excuse me just a second. He led the adoption and integration of the American Express A-Certify system, which uses artificial intelligence technologies to significantly drive down the incident of credit card fraud. The AI initiatives in this space are clearly in Gene's wheelhouse. So Gene will be followed today by Tawhid Ahmed, who will provide what I refer to as the path forward. Now, he'll be looking at ways to both detect and correct the potential anomalies that are particular to the AI implementations that we're talking about. So let me tell you a little bit about Tawhid, okay? Because he also speaks with authority. He has over 26 years of system design, development, and direct leadership experience in IT. He's a former division chief at World Bank, which was basically, he had the CIO title before that title even existed. So recently he's been consulting as a senior instructor in the area of web application security. And he's become our resident subject matter expert in the security of AI arena, which is, of course, the topic for today. So we'll close that with Q&A and some concluding remarks. Now, let's answer the first question. Who's SPS? Okay, well, we're headquartered in Rockville, Maryland, just outside of DC. We've been around for over 25 years, providing full range of innovative and leading edge solutions for our clients. We do cool stuff, basically. Our value proposition is defined by the acronym SCALE, which it includes security services, cloud services, AI development services, learning and events. And these services reflect our client's ecosystem. They allow us to bring fully comprehensive solutions to the table. And net it out, we're basically in the business of taking our clients to the next level. That's what we do. So we're also pretty good at it. We win awards, and as you can see on this one, IBM kind of likes us. I'm not going to walk you through each one of these, but suffice it to say, we're good at what we do. And then, more importantly, why are we here today? So let's talk about that. All right, start out with artificial intelligence. Everybody here knows what that is. All right, maybe some of you are even in the process of deploying or have deployed AI solutions. So everybody has that base. But be careful. As this area is just starting to really take form, we're also beginning to see an interesting and potentially hazardous exposure. The very factors that make AI so powerful can also wrap in potential underlying biases, sometimes intentional, sometimes not. So in this webinar, you'll get a better understanding of the problem. We'll walk you through the ways to identify the exposures and, more importantly, provide tools and processes to address these areas. So to discuss what I call the nature of the beast, I turn the presentation over to Gene Willard. Gene, take it away.
Thank you, Wade. Just want to make sure everyone can see my presentation.
Not yet, Gene.
Not yet.
How about now?
Still not there.
Wade, you stopped presenting, right?
I did.
I think you may still be sharing, or someone else may still be sharing.
Let me reshare. And I'll stop share.
Okay.
See it now, Jean.
Okay, good. Thank you. Well, I want to start out by thanking everyone for their time today, and I want to thank Wade for his introduction. As Wade mentioned, our webinar topic is how to secure and monitor your AI models. And the objectives of our webinar are really twofold. First, to surface and discuss some key risks in the development of your AI applications, which I will lead. And second, to introduce you to new IBM software solutions that can help you manage those risks across all of the prevailing AI development and runtime platforms, not just Watson, but Amazon SageMaker and Azure Machine Learning. Tawhid Ahmed will lead this part of the presentation. So to meet our first objective and help explain the problem we're trying to address today, our agenda will initially evaluate two basic types of AI applications: knowledge management applications and machine learning applications. We will then discuss some of the key challenges facing early adopters of AI, and in particular in the governance, risk, and compliance areas, what we abbreviate as GRC. We will then take a look at some example AI applications that pose some of these GRC challenges. Let's begin by making some distinctions between two broad categories of AI applications to help define the problem we're trying to solve. Knowledge management applications build from the business domain expertise of subject matter experts and their AI developers to solve important business problems. These applications typically use a predefined set of business rules to evaluate transaction data and then make recommendations regarding how best to optimize business results based on these rules and the attributes of the data. With advances in cloud architectures and AI platform as a service, these applications have become much easier to develop versus when one of my teams developed, deployed, and operated a knowledge management application for a major hospitality company back in the early 1990s. But these applications remain highly dependent on and limited by their human domain experts in terms of their range and depth of knowledge and the business value of the problems they can address. Machine learning applications, or what we used to call neural networks, have also greatly benefited from more mature algorithms and from cloud architectures. New data sources available in the cloud also now complement transaction data as sources of knowledge. But machine learning applications can also learn and solve problems independently of human domain experts and at a much faster rate, enabling rapid progress on what may previously have been viewed as intractable problems. But there are also potential risks associated with this unsupervised learning, such as the possibility of bias and inaccuracies in the training data and the algorithms, questions about the fairness and transparency of the business recommendations, and the trust that affected groups place in the algorithms. Finally, like any other business application, the machine learning training data and the models can be susceptible to security vulnerabilities and attacks by adversaries. These statistics are drawn from a survey of early adopters of AI conducted by Deloitte. The study cites some well-understood skills gaps faced by early adopters and the challenges in acquiring and integrating the requisite data to solve business problems. Also note the concern about data privacy as new sources of data resident in the cloud are related to transaction data to acquire new knowledge about customers, employees, and supply chain partners. Unintended disclosure of sensitive information constitutes one of several GRC issues facing early adopters of AI. Also note the concerns with cybersecurity, the incidences of an AI breach, and the impact these breaches are having on AI initiatives. Despite these risks and concerns, the benefits of AI are leading a sizable number of enterprises to move forward with their initiatives. In addition to privacy concerns, there are other risks related to the data sets used to train the models. Bias in the training data and the models can introduce questions about the accuracy and completeness of the training data, and whether or not affected groups are treated fairly by the decisions models make and their related recommendations. There is also the need for transparency in how the models make decisions. AI applications will be successful only if there is broad trust in the algorithms by the affected groups. Take the example of autonomous vehicles, which rely heavily on machine learning applications. With domestic and international traffic congestion, accidents and fatalities, and greenhouse gas emissions, all statistically heading in the wrong direction, surveys show that many consumers generally understand the future need for driverless vehicles, but relatively few consumers understand and trust the way driverless vehicles make decisions affecting their safety. Finally, given the number of AI breaches suffered by early adopters cited in the Deloitte study, there is the risk posed by adversaries who seek to introduce bias in the training data and in the algorithms for the sole purpose of achieving an outcome favorable only to them. The GRC issues and use cases are several and call for a new set of tools that can manage them. And these tools must work across all the prevailing AI platforms, given that many enterprises may choose more than one AI platform to solve their business problems. Here are a few use cases illustrating the GRC issues. Some of them tie back to compliance and regulatory requirements. As an example, enterprises who grant loans to consumers and use machine learning applications to help make loan decisions are regulated by the Fair Credit Reporting Act, which requires that they explain to consumers their credit worthiness ratings and related loan decisions. The criminal justice system is beginning to use machine learning applications to help them predict the recidivism rate for individual criminals and use these predictions to make parole decisions. But they are discovering that bias in the training data can introduce errors in model predictions and recommendations. An MIT computer science doctoral student demonstrated as part of her dissertation that some of the prevailing domestic US and Chinese AI platforms had gender and racial bias problems in their facial recognition algorithms. And finally, there's less information on AI breaches, but we know they are occurring and discouraging some public and private sector enterprises from advancing their AI initiatives. In this regard, an AI application is really no different than any other business application and must be protected by a defense in-depth security model that includes appropriate data and application security layers. The good news is that IBM is actively developing open, technology-agnostic solutions to address these GRC issues. Here to introduce us to these solutions is Tauhid Ahmed. I will now turn the presentation over to Tauhid.
Thank you, Wade. I will start sharing my screen. Are you able to see the screen?
Yes.
So to continue from where Jean left off, we are going to be looking at the solutions to the kinds of problems that Jean had identified in the previous section. And these particular solutions that we are going to be discussing today were introduced quite recently to 2018 by IBM in the form of Python libraries. And they provide the framework for easy extensibility over time through use of abstract classes and standardized external interfaces. They're technology agnostic and deal with AI models built in a variety of platforms, can run across different clouds, IBM Cloud or Azure. These tools are discussed within the framework of the specific problems that are designed to address that Jean had identified, and where appropriate in the broader context of the AI model building process. So we are looking at the tools in the broad context that you would have to try to solve the problems in the real world. And as far as so what I hope is if you're already working with AI, then these kinds of solutions will set you on the path towards appropriately adding these tools to your repertoire. However, if even if you are not already, the proud owner of AI models, even if you're considering incorporating use of AI in your organization, I believe the broader context that I referred to earlier should help you, see and how you get started. And then these tools, I hope you will appreciate at the end, they are really very readily picked up. And if you are a Pythoneer, which is Python has become a cult of millions, I guess, and the Pythoneer is the black belts, and these people actually add to these libraries. So these libraries that IBM has put up, they are available on GitHub with liberal licenses, excellent documentation, even by Python standards, and are designed for extensibility as will be described in the presentation. And so this will hopefully encourage you to contribute towards building protections against AI. For example, the first issue that we are going to be dealing with is the malicious use of AI. So that's certainly something a worthy cause to try and promote. And the types of attacks that we need to be, defending against. Camouflage. You won't hear this term too much in the AI world today, but that's really all it is. It's used, there are different terms which I find tongue twisters: adversarial example, adversarial perturbation, evasion attacks. But and the key feature is that an intentional feature perturbation of an image can wreak havoc with AI, and these examples will hopefully make it clear. You make a single pixel change in a picture of a dog and it becomes a horse for the AI model, although the picture looks unchanged to the human eye. Post-it note stuck on a highway stop sign can fool AI into ignoring it. So serious issues that are, have to be addressed if we are going to make benefit from this new technology. The second kind of attack is hallucination. Again, just a everyday term, which I find easier to use, but here the generative adversarial networks, GANs, were introduced in a theoretical paper in 2014. And as you would expect for a hallucination to do, it fools the AI into thinking that, there's something exists maybe in front of the car that does not. And the third is brainwashing. Again, everyday term, but the technical term is poisoning attack. And I should add, all these technical terms are rooted in the underlying science from which they have arisen. So, the training here, the training data to the machine is deliberately tainted to make the building of the AI model itself, raise the AI model to be brainwashed, basically, be able to, and the big danger here is that the training data that is used to make the AI model more robust is often picked up from social media. It has to be. And social media, as you know, is a wild west out there. Anyone can come in and put data in, and we all know about that. So these are serious issues that need to be protected against. And for this, IBM has contributed to society by adding something called the adversarial robustness toolbox. Introduced in 2018 as a open source Python library, currently labeled by IBM as being at the development stage, but it looks pretty developed to me. I mean, they've got a number of modules to test for robustness against different kinds of attacks of the kind I mentioned yesterday. Designed for ease of incorporation in an AI model. There are a number of modules already implemented in this library, and largely focused on visual recognition systems at this time. And the aim is to expand them into speech and text recognition, and that's coming down the path. Just to give you an idea of how this library is structured, consists of a number of modules, attack methods, which can be of the hallucination kind, or they can be of the camouflage kind, and then so those models are used to detect the vulnerabilities in the AI model, or to train it. And so the second part is the AI, the artclass classifier, which basically provides a standard API for models built on different platforms. So again, platform agnostic. And then defense techniques to protect against and train the model to become robust, and some support modules. And here we now switch to the, let's take a look at this thing online. So as I mentioned, this is available on GitHub, which is, widely used, and you can fork this, bring everything, all this work that has been done is available for you to fork over and contribute wherever you think. But before you start contributing, if you want to learn more, they have notebooks and examples. So there's plenty of material to help you get started, and even if you're new to this business. So, or if you wish to contribute, obviously you can fork it and actually do what you can to improve on it, add new submodules perhaps. So this is the adversarial robustness toolbox, which if you are looking for something in this area, would be the place to go to. And let me switch back to my presentation. One more thing I should add, as with any technology, I mean, tools are great, but to make good use of them, you need, some kind of a strategy, tactics, how to use those tools, so you don't shoot yourself. So in order to be cost effective, adversarial robustness needs to be approached from a broad business perspective. And fortunately, industry frameworks already exist for this related areas of security concern, particularly web application security, which I think you may have heard of these, various maturity models that help organizations make good use of tools that IBM has made available in that area. And I should add, I mean, a lot of vendors are operating in that area as well as they are in the area of these tools that I'm mentioning. And these frameworks are clearly extensible. So this would be one takeaway I would imagine would be useful to as you start using and incorporating this particular library in your portfolio. The second issue that Jean had mentioned was bias. So now we look at the two tools that are available now and how they fit together. Bias is defined to be an unfavorable outcome for a monitored group, and of course, this example makes it clear to like a female loan applicants may be rejected at higher rates for some reason by the model. So these are measured by fairness metrics. And bias can arise due to three reasons, and we'll be getting into a bit more depth later, but in the next slide. But I just wanted you to see this deficiencies in the raw data provided to the model. There can be under coverage, over coverage of a particular group in the data, for example. It could be deficiencies in feature engineering, and if this term looks new, then you'll be familiar with it in the next slide. AI model does not accurately reflect the organizational business model. That could be a defect in the feature engineering of the AI model, perhaps. And this is an example which I'll briefly mention in the next slide. Does not meet regulatory, and when all is said and done, maybe the business thinks it's perfectly good practice to do this, but if it does not meet regulatory requirements, then obviously that needs to be fixed. So, so this is the, if you're new to the AI business, this is the basic process through which you're developing AI models. And I need to emphasize on the left-hand side, this is where the creators, the human beings, ultimately, the AI model is as good as the human being. The man behind the gun is, a guy who actually knows what he has to do. So this is where the business philosophy or the model comes in. The raw data is data that the organization may have collected over the years, equivalent to experience that somebody gains. Maybe a loan officer in this example who has spent 30 years has gained experience on accepting, rejecting candidates. So we've got hard data over here. And then feature engineering means this is where the data scientist comes in and he works with the business experts, and they work together to see if we need to define the scope of the information that we are going to feed to the algorithms more broadly or more intelligently. There's tons of data cleaning that needs to be done, so that addresses the kinds of issues that I mentioned in the previous slide, over coverage and so forth. So when this part is done, you come up with the input data file, and after that, technology takes over basically, or rather the people, not technology, but I would call it the statisticians and mathematicians of decades ago and maybe even centuries ago, whose algorithms are now being used. So this is so now we move into these libraries. In Python, for example, you've got scikit and other libraries which are readily available. All that human effort and knowledge is freely available to all. So what they do is they split up the data into training data and test data. So they're basically taking hard experience and taking some selected data from there, feeding it to the algorithms. And the algorithms, then this is where the data scientist again comes in. He needs to define the problem very clearly and needs to make sure the algorithms are appropriate to this situation. So that's again where you've got human intervention. And after that, you have this test data and you come up with the train model, and then you have the final product. All we're doing is projecting, but that's all human activity is about. We're trying to plan a project in the future. And the way these modules fit together, AIF 360, which is one of the tools we'll be going over, it has three sets of modules. The pre-processing module that you can use to fix the data at the input data stage. The post-processing module, which goes to the other extreme, and it doesn't care what the internal process with the model is. It looks at the final results, does its own thing, and fixes it for bias, for example. And they have in-processing modules that work within these training algorithms, and they do the thing to remove bias. Now, this is one of the tools. The other one is OpenScale, which I'll come to the end because that will be the subject of most of this discussion later on. But before I move on, I should add that this may be a good if you detect bias, that can be a symptom of a deeper of a root cause. Maybe your model isn't right. Isn't designed right. So this is where the data scientist needs to rethink these feature engineering and needs to work closely with people who understand the business, who know the practicalities, and try to figure out why is it causing the bias. So this is one area of intervention I would strongly recommend. You will still need these IBM tools to detect bias in any case, but for correction, it's better to go as early as you can into the life cycle. And the second area, which is even more, feature engineering is considered to be a big deal. Sky's the limit as far as your imagination and competence goes. But before that, you've got organizational rethink, where you can change the entire business philosophy or model. And just to give you an example, we are going to be looking at the German credit market data. We added one way to fix bias, obviously, is to get help from these algorithms. Another is to introduce a microcredit scheme, which is exactly what was done about 30 years ago in Bangladesh. A man thought that maybe women are sound borrowers, and based on that philosophy, he started lending to women whom nobody would lend to before. The banks won't talk to them, and that microcredit business has become a multi-billion-dollar business, which is spread out all over the world. It's changed the future of nations. I was associated with it when I was at the World Bank, so I saw it firsthand. So these are very powerful things. And that man who came up with this idea won the Nobel Prize, Yunus. So coming back to our tools. The projection. So the third tool that IBM provides external processing of the data. And what it does here is all of that slide that I had in the, is now a black box. So it doesn't matter what kind of an application you got, what kind of a platform you're on. We've got IBM OpenScale on the right-hand side. And it provides a user interface, which we'll be going through, which is a very rich source of information for somebody interested in bias correction, and also as an unbiased model that you can use for your purposes. It helps you. Now, and all it calls for is you subscribe to it, you provided some historical payloads, and you can get started, and then you can have online data flows where transactions are coming in, say on a daily basis, so you can keep an eye on how the model is doing over time. And so all this is done through REST API, so it's total platform independent. You just need to send it the data. And we'll be looking at this, and this is another thing I would, should be a takeaway for you, because as we'll see later on, it's really very simple to become familiar with this, thanks to all the hard work that's been done here. And provides, the second tool, of course, is AI Fairness, where you saw those so there you got provides basic functionality for machine language, uses the familiar scikit terminology, so it's already familiar to the user community. It's open source, and those three stages we've already seen. And let me take you to this very nice website. I mean, I really love these websites because I really enjoyed working with all the things they've done here. And here you'll see again, they put together web demos, videos, read a paper, use tutorials, ask questions, view notebooks. So they've got tons of material for you. If you are into, understanding these various indices. So this is if you're thinking of next steps, another thing to take a look at. And now we come to, how do you call it, the piece de resistance, IBM OpenScale demo. And to introduce you to it, just to give you a little flavor for the kind of application that we're dealing with, it's a credit application processing system, the German credit system. And the nature of the input data should be pretty familiar to you if you ever applied for a loan. It's basically the checking status, loan duration, and so forth, kinds of information that the banker thinks you would need to figure out if you'll return their money to them someday. And this is what the AI model is being fed. It's been given historical information that people with these characteristics, they ended up paying or not paying, repaying the loans or not. You'll see these terms a lot. If you're in the machine language world, features should be no mystery to you. But if you're in the systems analysis, database design world, then attributes, same thing. And if you're a mathematician, or then independent variables that go towards determining the outcome, whether or not the loan is being paid back. And here we have the fairness attribute. So the gender of the person. And later we'll see how OpenScale, protects against gender bias. It could also be age, for example, but it's really up to you what you want to set as in the context of your environment, because so just think broadly on which variables you're trying to protect against for your own business reasons or maybe for regulatory reasons. And I just identified this field, foreign worker. In this German context, it does make sense to not consider it a discrimination, because there's a issue about temporary workers who may be leaving the country soon, so they may not be as. So this could be considered an independent factor. So now we go to the online demo, and let me switch over. So here we have the IBM Watson OpenScale, the display that I had mentioned earlier. And we are at the main, the first page where it's pretty straightforward. What it says is it's got deployments, which are, and one of them is being monitored. So what this is telling us is that for this particular OpenScale deployment, which I actually did for purposes of this presentation, we have only one AI model that's being used. You could have many such boxes over here, so you can use it to monitor bias or other things in as many of your AI models as you wish. Gives you alerts if there's issue that, because remember it's a real-time system, it's metrics are being updated hourly. So as you process new transactions, it's keeping an eye so you don't mess up and find out 2 years later that you've been doing everything's biased. It catches you on time. And the two metrics that it's really interested in is accuracy and fairness. And time has shown that fairness is pretty straightforward. For accuracy, there's a need for there were many different measures for this, and as a result of experience with use of the system with the big users, IBM has realized that they needed to improve on this. So they have a beta version that is coming down the pike, within a few weeks, I guess. And so I would like to switch to that. because that's really, we want you to leave this presentation, seeing what's going to be there in a few weeks, not what's going to be changed, left behind. And you will see that there was no perceptible change here. It's still the same thing because the changes have all been under the hood. So I'm going to now click here and we start digging into the detail, and you'll see just how powerful this application is. And here we go. On the left-hand side, you have a whole set of metrics. Area under ROC. If you're a World War II buff, you would love this one because this is ROC is a term, receiver operating characteristics, that they came up with to determine whether the British did, to see if the incoming German planes were true positives, meaning they were really German planes, or whether they were a flock of birds. So this has to do with true positives and true negatives, and this has become one major measure of the accuracy, because as you remember, I mean, ultimately all this work that is done in AI modeling, everything, it's about how good your projections are. If you're good at, so this is why there is so much demand from the user community, and IBM has responded by coming up with a whole bunch of such measures. And it goes down here for model performance. So they've greatly enriched this, and that's coming down soon. The second thing I would like to, since this is a demo only thing, this thing may not look too interesting here because there is no data coming in on May 23rd, because I put up this thing a little while back. And so I'm going to pick up, and I actually used one of the tutorials to do this. So the tutorial come, and if you do this, you'll have it set up too. So you come up with 7 days worth of transactions that it comes with, and this is what it's displaying over here. So these are the ones that become interesting. So let me just click on one of these. This was like April 25th or something. There we go. We have bias. Monitored groups. This is a term that you'll hear often in this business, because monitored is, females. It could be ethnic minorities, perhaps, or something, some such, or age, some age group, and the reference group is, if it's female, then this is male. So they're monitoring against that, and looks like the females during this time had a 94% success rate in getting their applications accepted, or to be technical, I mean, it's really to be classified as no risk, and whereas 99% of the males did. So what OpenScale has done for you is it's taken the payload and perturbed the data. So perturbation, you may remember from the earlier slide, that was used for bad purposes, to hallucinate, cause hallucinations for AI models and all. But here, the perturbation is being done for a good cause, which is what OpenScale does is it takes a look at the females who were considered on the margin, like 50% probability. So they were kind of marginal cases who could be no risk, and it could put them in the unfavorable group, meaning that they are risky. So it took those women and changed that gender field that I showed you earlier from female to male. And then it took males who were considered acceptable, but again, 50% margin, and it changed their gender record to switch it to female. And that's perturbation. I mean, that's really all it is. It can be done in a much broader scale, but this is, so here, so then it used that. And then what IBM does is it gives you, and you can look for the monitored feature is both sex and age, and this is the time when these transactions were received, so it's all time sensitive. Now we dig deeper, because the next question that arises is, are these all, I mean, let's just focus on the biased transactions, for example. So these are the ones that are causing it to OpenScale to alert you to the fact that there may be bias going on here. So if you want to take a closer look, you can go down to the individual transaction level. And here it makes very clear exactly how, what's going on. And these are the factors from that loan application that it took into account. And it's looking at that too. And so the explainability, which is a term you'll hear a lot about in this business nowadays. So this is explainability for you. It goes right down to the individual transaction levels and tells you a good deal of information so you can explain why the bias took place. So at this point, I'm going to switch back to the next steps in your path towards. Yeah, the next step should be, I highly recommend this, going to this SDK advanced tutorial, and don't let advanced fool you, because an idiot like me could go through it without any problems. So go to this advanced tutorial. It's sitting right here. Let me see if I can. I may have to switch to it. It's not. Oh, I see. I don't have it on current slide. Yeah, excuse me. All right. Yeah, so this is it. Yeah, it's just point and click and just go through all this. And if you're familiar, and you'll it takes you step by step. And the other thing, I will leave this presentation with leaving you with one last thing. Within this SDK tutorial, there is a very nice Jupyter notebook. And if you've not worked with Jupyter notebooks, I mean, I think you should, because again, another, if you're a Python programmer particularly, but even in other fields. So it comes with this Jupyter notebook that takes you through all these series of steps from beginning to end, and where you're dealing with a lot of powerful technology on the cloud, Spark, and all kinds of AI modules, those algorithms we were talking about, and it sets everything up for you all the way to that display that I was showing you. So you get a good feel for OpenScale, and it's very elegantly put together, and I congratulate IBM on doing such a fine job here. And on that, I shall end my presentation and hand over to Wade.
Actually, I think you can stay where you are, and just forward to the next slide. Actually, forward 2 slides up, if you would.
Alrighty.
I want to get to the questions. So, while he's doing that, if there are questions from the audience, Mary, I don't know whether you can unmute, or if you have questions that have been queued up, we can address those. Do that first. Yeah.
I don't see any of the any questions in the queue right now.
Okay. And if there are any questions from the field, if you unmute, we can address those. We'll give that a few seconds.
I just unmuted everybody, so you feel free to speak up if you have any questions.
And we'll just give that a few seconds. And let's go ahead and mute it back up. I think if there were hands or questions, we'd have seen them. So, thank you very much, Tauhid, and also to Jean. This is.
Oh yeah, just muted Wade. Wade, let me unmute you. Uh-oh. Where is Wade? Unmute. Wade, I just unmuted. I had to unmute you. Sorry.
Okay. All right. I don't know what if at what point you did, but the point I was making first off, I wanted to thank both Jean and Tauhid for doing an outstanding job of laying this out. From my perspective, this is very eye-opening stuff. I mean, the underlying assumption for most of us, at least for me, is that we were on pretty safe ground here, with the artificial intelligence, as powerful as it is. As Jean showed us, the AI models, as good as they may be, can also mask threats, and either intentional or otherwise, that can put businesses at risk. I mean, and you think about it, it makes sense. They can be biased. They can be gamed. They work on inference, and if the underlying data is biased, their conclusions will be biased, which kind of makes sense. So it's not something that I would have thought intuitively, but once you drill down, it makes a lot of sense. So thank you, Gene, for exposing that piece of it. And then what Tahid brought to us were 3 tools, all available today, that can help you address these exposures now that you know that they're there. I mean, you start out with the adversarial robustness toolbox, or ART. He also introduced the AIF, which is the AI Fairness 360 tool set. And then finally, the sort of the granddaddy at this point is IBM's Open Scale. And these can be used both to detect and to remove the biases that you encounter. So this, to me, again, this is not something that I would have thought coming in. So as we started to delve into this, this was very educational for me. From a next step perspective, what we'd like to do is to offer the following. One is an initial risk assessment of your AI project. You bring that to us, we can talk. And then secondly, also, if you're interested, provide a proof of technology so that you can actually get underneath the covers and see how some of these processes work. So thanks again to the team for putting this together, and to you for your time. If you're interested, please contact me at the email address that you see listed below. And we thank you for your attention and wish you a good rest of the day. And Mary, at this point, we can go ahead and adjourn.
Okay, I'll be stopping the recording now. Thank you very much for coming today.